Chapter 2.2, Basic Differentiation Rules and Rates of Change, Day 3. Today, what we're going to focus on is trig functions. We're going to find the derivative of sine and cosine. Starting with sine. Now remember the limit definition of derivative. Y prime equals the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. We're going to use that to find our derivative of sine. Now once we find the derivative of sine, let's remember it because we don't want to use the limit definition every time. So we'll start y prime equals the limit as delta x approaches 0, the sine of x plus delta x minus the sine of x all over delta x. Now first off, we need to go back to our pre-calc days. Remember what the sum and difference formula for trig was. For sine, we can simplify this out. The limit of delta x approaching 0, sine x cosine delta x plus cosine x sine delta x minus the sine of x all over delta x. Now from here, let's take a look. We got a sine x in this expression and a negative sine x in that expression. So what we want to do here is group those two expressions together, meaning rewrite it so they're by each other, and factor out the sign. So I'm going to do that. The limit as delta x approaches 0 will be sine x, sine x. And then what's left here is cosine delta x minus, and what's left on the other one is 1 plus cosine x sine delta x all over delta x. Let's get to a clean sheet. All right, so what we should notice here is this expression is pretty similar to that expression for the special trig limits. It's almost exactly the same, except we need it to be 1 minus cosine x instead of 1, or cosine x minus 1, which isn't too bad. We can just multiply by, factor out a negative 1. So we'll do that. We'll factor out a negative 1. I'm going to also split this into two fractions. Remember the 2 on 1 we did for the derivative shortcuts? That works for limits too. So what I'm going to do, I'm going to rewrite this. The limit as delta x approaches 0 of sine x, or negative sine x, I'm factoring out the negative, 1 minus cosine of delta x over delta x, plus cosine x sine delta x over delta x. Now remembering our special trig rules, right there, 1 minus cosine delta x over delta x, as delta x approaches 0 is 0. So this whole expression then is 0. Right here, sine delta x over delta x approaches 1. So as delta x approaches 0, the only thing that's left is the cosine of x. So when f of x equals the sine of x, f prime of x equals the cosine of x. Applying the same thing to cosine, applying our limit definition of the derivative, delta x approaches 0, we got cosine x plus delta x minus cosine of x all over delta x. Again, going back to pre-calc, applying the sum and difference formula to our cosine. This we can simplify, or actually expand, to the cosine of x, the cosine of delta x, minus the sine of x, the sine of delta x, minus the cosine of x, all over delta x. And again, we got a cosine x here and a cosine x there. We will group them and factor it. So we got the limit as delta x approaches 0. Cosine x, and what's left is cosine delta x minus 1 minus sine x, sine delta x, all over delta x. From here, I want to rearrange this and split to a 2 by 1. So as I do that, I'll get the limit, delta x approaches 0, of negative cosine x times 1 minus cosine delta x over delta x minus sine x sine delta x over delta x. Using our special trig limits, this is 0, so the full thing falls off. This is 1, so as delta x approaches 0, what's left is the negative sine of x. So the derivative of cosine is negative sine x. So as we take a look at this, y equals sine x, therefore y prime equals cosine x. All right. If we leap and go to cosine, derivative of cosine is negative sine. Well, let's go to negative sine. Derivative of negative sine, well, sine is cosine, and then we bring the negative with. Well, let's go take negative cosine, find that derivative. Derivative of negative cosine is negative sine. But since there's already a negative there, we double the negative. A negative is positive. So the derivative of negative cosine is sine. So you can see the sine and the cosine kind of loop around. There's a 4-function loop for finding the derivatives of sine and cosine. Let's look at an example. F of x equals 2 cube root of x plus 14 over x squared minus the sine of 3 times the sine of x. First, we'll rewrite it so we don't have radicals or fractions, right? Or exponent or variables in our fractions. So we'll do this first. F of x equals 2x to the 1/3 plus 14x to the negative 2 minus 3 sine of x. And then we'll do each derivative separately. 2x to the 1/3, we'll take 2 times 1/3 is 2/3. Just take your numerators times each other. And then x to the 1/3, we power it down. Remember, we take the numerator minus the denominator. 1 minus 3 is negative 2 over 3. Negative 2 times 14 is negative 28. X to the negative 2 minus 1 is negative 3. Then here we got a constant multiple rule. And then minus 3 times the derivative of sine is cosine. So f of x equals 2 cube root of x plus 14 over x squared minus 3 sine x. And then the derivative of that is 2/3 x to the negative 2/3 minus 28x to the negative 3 minus 3 cosine of x. If you would like, you can leave it like that. Otherwise, you can rewrite it in radical and fractional form, but it's not necessary. All right? Find the values of a and b if the tangent to y equals a over x squared plus b at 2, 4 has the slope of negative 2. All right, so let's first realize that slope of the tangent line means derivative. So we need to find the derivative here. I'm going to rewrite this without fractions. And then I'm going to find the derivative. Since a is what I'm looking for, I'm going to treat a as a constant, b as a constant. So my variables, dy dx, will be, as we take our derivative, negative 2a x to the negative 3, and then b is a constant. This one, since I'm trying to set it equal to something, this one might be a good idea to rewrite it back into a fraction. So that's my derivative. I know that at 2, 4, my derivative is negative 2. So that means the x value is 3. So negative 2 equals negative 2a over x to the third. But my x value is 2, so that means 2 to the third is 8. And now I just solve for a. Let's multiply to get rid of the fraction. Negative 16 equals negative 2a. Divide by negative 2, and a is 8. Plug in everything I know into the original equation. Y is 4. A is 8. X squared, well, x is 2, so 2 squared is 4. I still don't know b, but I can have enough to solve it. 4 equals 2 plus b, so b equals 2. So in summary, the main idea today, the derivative of sine is cosine, and the derivative of cosine is negative sine. If you keep taking the derivatives there, they'll loop around for a total of 4 functions that are derivatives of each other.